Okay, this is a review. I'm going to go ahead and do a review lecture for exam 3. Okay, the first thing that covers is increasing and decreasing functions and when the function is greater than 0 or less than 0, and you have to keep straight which is which. Okay, so if you have an increasing or decreasing function, I'm just going to draw a general graph, okay? Here's a function, and it can be cubic or quartic, okay? These are different questions than this, so you got to keep straight which is which. Increasing and decreasing is asking about slope. When is the slope going up? When is it going down? When is it going up? These are dependent on x values only. You don't even look at the y. You don't care about the y. So the x values for when this is increasing would be a minus infinity, and then it stops increasing. Let's say this is a negative 2. So it would be a negative 2 because that is the x value, not the y. I don't even care what the y is. You only want the x. And then it's decreasing from here to here. Let's call that 4. Okay, so we'll mark all this. All right, so it's increasing from a minus infinity until you get to 2, which is also a maximum. Remember, we've done maximums too. So there's a lot of things in this graph you should know now. You know, it's increasing from minus infinity to minus 2. It's decreasing from minus 2 till it gets here. So the decrease is going to be from a negative 2 down to you get to 1, 2, 3, 4. Again, we're just interested in x, don't even care what the y is, okay? And then it's increasing again, so you're going to put a union sign because there's more than one increasing interval, from 4 on to infinity, okay? And that would be your intervals of increase, would be this interval, and it's when the slope is positive. You're looking when the slope is positive, which is different from these. This is asking when the y values are positive, so you have to keep that straight. Increase and decrease is a slope. This is dealing with slope, okay? And that would be how you would write it. If you were looking for when f of x is greater than or equal to 0, or less than or equal to 0, you're looking at an entirely different question. That question is this does not involve slope. This involves the y values and their signs. Okay? So when is it positive is asking when are the y values positive. So slope has nothing to do with this. Here's your 0 for your y-axis. Y equals 0. This is your x-axis, but y equals 0 here, y is positive up here, and y is negative down here. Okay, so the intervals when f of x is greater than 0 would be everything that's above the x-axis. All right, so that would be from here to here, it's above the x-axis, and then it goes under it. So that would be 1, 2, 3, 4, negative 4 to 1.5. So f of x is greater than 0 from a negative 4 to 1.5. And that would be round brackets because it's not equal to 0. F of x is greater than or equal to 0 from a negative 4 to 1.5. Square brackets, because equal to 0 means when it's on the axis it's actually equal. Okay, so there's a difference. And then you would do, is it above the graph? Then it goes under the graph. Then it goes above the graph again. So here again you have it's above the graph, and here it's above the graph. It starts above the graph again at 1, 2, 3, 4, 5, 6, 7. So you would do union 7 to infinity. And here you would just do the same thing, but it would be square bracket 7. Now infinity would always have a round bracket. Am I on the, can you check to see if this is showing? I moved over all the way over here. Go ahead and scoot the whole thing over. Okay, so basically, whether it's greater than 0, greater than or equal to 0, just depends on what kind of bracket you use, except for at infinity, it's always square brackets. Okay, that never changes. And that's asking, again, the difference between this is asking about slope. Increasing and decreasing is when is it going up and down. This is asking when is the function value, which remember f of x is y. When is y greater than or equal to 0 is what that's asking, okay? Different question, different answer. In this case, again, but the thing is, for both of them, you'll notice, you use the x values. You don't ever use the y's to answer either one of these questions. You just use the x values, but the x values you're looking for are different. Here the x values are your intercepts, and here the x values were your maximum and minimum points. Okay, so the x value you're hunting down is different for the question. And again, if you're looking for f of x is less than 0, same exact thing. Now you're looking for when it's under the graph. When is the y value less than 0. That's what you want to know. Y values are less than 0 here, which starts at a minus infinity as it comes up and then it hits 0. So that would be a minus infinity, and then it stops being less than 0 at a negative 4. And then that would be unioned with, it's less than 0 between here, which is 1.5 to 7. And these are round because it's strictly less than. For less than or equal to 0, you would have, well, you would still have round for minus infinity, but you would have square for 4 and square for 1/2. Square. Okay? So that's the only difference. So you got to keep straight what you're being asked and what you're being told to find. Again, slope is increasing and decreasing. These kind of questions are asking for the y values. Okay? And that's what you do with those. Now, from this graph, you could also find another piece of information, or several pieces of information. And this is what this whole section is about, is identifying these characteristics of the graph. You could also be asked to find the intercepts. Now notice, for both of these questions I just worked, I didn't even put tick marks on the y, because I don't need to know anything about the y. For increasing and decreasing, and f of x is greater than or less than 0, you don't even need to know what the y values are. There's nothing on here that shows a y value because they're not essential to answering the questions. It's purely in terms of x, okay? Now, to answer the next question, you do need to know y values. Now, the next characteristics that you can find, so I'm going to list these across the top. We've talked about characteristics of increase and decrease. We've talked about f of x, which is your y values being greater than or equal to or less than or equal to. Now we're going to talk about local maximum and minimum points. Okay? Now hopefully by now you know the local max and min, this would be a local max. It's the point, the absolute max, the absolute highest point on this graph would be infinity because it absolutely gets high. We're just looking for local. Local means just relative to the area that the graph is, and not including the endpoints. You're talking about basically the bumps, all right? So this would be a local max, and this would be a local min. And when you do maximum, minimum, you need to give me an x and a y, okay? Now, we have the, in the quadratics, when you have a quadratic, you can find your local max or local min by finding the vertex. There is no vertex formula for stuff like this, so you'll have to find it off of the graph itself. Your x here is at a negative 2, and the y value here is going to be at 4. So here you need to give me a point. It's not a local max if you just give me an x. It has to be a point. These are points. And this point right here would be 1, 2, 3, what is that, 4? And 1, 2, 3, well, let's see. It's supposed to be at 4. So 4 minus 4. And that would be your local min. So local min and local max are actual points on the graph where the graph curves and changes direction is what it boils down to. Don't include the endpoints. Those are obviously maximums, but they're not what we're interested in. We're interested in where they change direction. And that would be a local max or a local min. You can also find off of a graph the intercepts, which includes x and y. And hopefully by now you know the difference between them and what they mean. The x-intercepts in this case are going to be x equals where it crosses the graph. You have a negative 4 as an x-intercept, you have 1.5 as an x-intercept, and you have 2, 3, 4, 5, 6, 7 as an intercept, okay? Your y-intercept, which you will never have more than one, or it's not a function. Remember, a function can't cross and have two y's for the same value, so functions can have more than one x-intercept. They can't have more than one y. In this case, the y-intercept is where it goes through the point, so that would be y equals 3. Okay, and you could write these as points. That would be a minus 4, 0, 1.5, 0, and 7 and 0. And this would be written as 0, 3. So when you have x-intercepts, your y's are always 0. When you have y-intercepts, your x's are always 0.